In this video, we're going to look at how to calculate the determinant and inverse of 2 by 2 matrices. So let's say we have a 2 by 2 matrix A, and the elements of A are A, B, C, D. Now, the determinant of A, which we can denote as det A, or we can denote as A with two vertical lines either side, or we can denote as the matrix with vertical lines either side, A, B, C, D with vertical lines. These all mean det A. Well, that's equal to, this is just a formula you need to learn. For a 2 by 2 matrix, the determinant is AD minus BC. So it's the two elements on the AD diagonal subtracted by the two elements on the BC diagonal. So here's a simple example. E.g., if A equals 1, 2, 3, 4, then det A is equal to, well, the AD elements is 1 times 4, and the BC elements is 2 times 2. We subtract 2 times 3. So this is 4 minus 6, which is minus 2. Okay, fairly straightforward. Let's just do another one. A equals, let's not call it A, let's call it B. If B was equal to 3, 2, minus 1, 1, then det B is equal to 3 times 1 minus, the other is 2 times minus 1 is my other diagonal. This is 3 minus 2 is 3 plus 2 is equal to 5. Okay, so that's how to work out the determinant of a 2 by 2 matrix. If you're wondering what the determinant means, well, when you get on later to linear transformations, you'll see that the determinant of a matrix tells you the area scale factor when you apply this matrix as a linear transformation. Anyway, you'll get to that at a later point. Now let's look at inverses. So let's just clear what we've got so far. So if you have a matrix for matrix A, the inverse, and we denote the inverse by A to the minus 1. The inverse of A to the minus 1 is the matrix such that A multiplied by A to the minus 1 is the same as A to the minus 1 multiplied by A, and these are both equal to the identity matrix, which for 2 by 2 matrices looks like that. So the matrix A to the minus 1 is the one that when you multiply it by A gives you this identity matrix 1, 0, 1, 0, 0, 1. And again, just like determinant, there's a formula for inverse. A to the minus 1 is given by 1 over det A of D minus B minus C A. Remember, this is when A equals A, B, C, D. So what happens, that AD diagonal we swap round, and the BC diagonal we negate, and then we divide this whole thing by the determinant of A. So let's do an example of this. So let's look at A equals 3, 2, minus 1, 1. Then then A to the minus 1 is equal to, well, 1 over det A. Well, this matrix we looked at earlier, and we worked out that the determinant of A was 5. So this is 1 over 5, and then we just have to do, we swap this 3, 1 diagonal, so it becomes 1, 3, and we negate the other diagonal, it becomes minus 2 plus 1. Okay, and we can multiply through by a fifth if we want. We get 0.2, 0.2 here. This is minus 0.4, and this is 0.6. And this is a to the minus 1. We just plug numbers into our formula. Let's just check that this is indeed the inverse. Remember what we said about inverse? The inverse of A is the matrix such that when you multiply A by its inverse, you get the identity matrix. So let's try to do that. So let's just let's try to do this calculation. Let's do A times by A to the minus 1. Well, that's 3, 2, minus 1, 1, times by 0.2 minus 0.4, 0.2, 0.6. Let's do some matrix multiplication. So we're going to do the first row of multiplied by the first column. So we get 3 times 0.2 plus 2 times 0.2. Then we get 3 times minus 0.4 plus 2 times 0.6. Then down here we get minus 1 times 0.2 plus 1 times 0.2, and we get minus 1 times minus 0.4 plus 1 times 0.6. Okay, let's work out this. 3 times 0.2, that's 0.6 plus 0.4, that's 1. Top right, 3 times minus 0.4 is minus 1.2 plus 2 times 0.6, that is 0. Bottom left, we get minus 0.2 plus 0.2 is 0, and bottom right we get plus 0.4 plus 0.6 is 1. And so we see we did indeed get this 1, 0, 0, 1 identity matrix. So this all worked out. We did indeed work out the inverse of A to the minus 1 correctly.